Hi everyone. Welcome back to the channel. In this series of lectures, we will try to solve and design solutions to some of the uh, data structure problems, more specifically, some of the lead code problems, how you should uh, design a solution or come up with a logical solution and then convert your logic into code. So, you know, these logic buildings are not easy and they might not come naturally to everyone. Secondly, for my experience, maybe I can come up with some of the solutions more easily because I have seen these problems in my career, and you may not have seen those problems or solved those problems or coded some of those solutions. But you don't have to demotivate yourself if you are not able to design a solution the way I am able to. It's just about experience. The more you code, the more you play with these problems, slowly and slowly, the time taken to solve a problem will keep going down. Initially, you might take an hour, 2 hour, or maybe throughout the day to solve or code a problem. But as you keep doing, the time will keep on increasing. So you don't have to demotivate yourself. Keep trying, and the failures should not demotivate you. So that's all I can say. Um, and okay, let's dive into a couple of problems and see how we come up with the solution. So I have Visual Studio Code opened. I am going to create a project. So I am going to create a project, and I am not going to create any of the build tools to compile my project. So I want to create a project in this location. Okay. So let's say I give it a name, code 1. And okay. So once you do that, you will get a new project where you will have a source directory and a app.java. So let's say the first problem I want to tackle is the LeetCode problem number 54, which is spiral matrix. So I'm going to right click here, new Java class, and I'm going to give it name spiral matrix LC 54. Okay. So let's say I will copy the LeetCode syntax for the function here, which looks like this. And I'm going to switch off the Copilot. Maybe I need to remove the Copilot plugin. Okay. Um, let's import java.utils.star. Wait a moment. Okay, I think I copied the C++ syntax. Okay, so this is the Java syntax. So how we are going to tackle this problem? Let's say I have this matrix. Okay, and the problem is I have to traverse this matrix in a spiral way. So I will go 1, 2, 3, 4. Then once I cannot go to the right, I am going to go down. So 8, 12. And when I cannot go down, I am going to traverse left. So 11, 10, 9. And when I am at the most left position, I will go up 5. And because I have already traversed the first row, I am not going to print 1 again. So I will go on to the right as soon as I reach 5, and then 6, and then 7. That's where my search should end. So let's try to build a solution in a, let's say, baby steps. So okay. Let's say I want to write a code. So the first thing we need to do is go from left to right. So let's see how I should be writing this code. From left to right, I need a for loop. I is equal to, let's say, 0. I less than. We need to go on the first row until I reach the last column. So, which means I need to go from 0 to the rightmost, right? And then I plus plus, and I'm going to add the result to this list. So if I need a result, let's say I will create a list integer result is equal to new list, new array list. Okay. Now what I'm going to do is I am going to add all my results to this result list. So which means matrix. Now I'm traversing my first row. So first row means row should be, let's say, 0, and column is going to increase, which means I, right? And I need to add this result, add to my results. Okay, let's just fix quickly the problems we are. I think array list is Okay, it's not utils, it's util. Okay, and I think I need to add java.util.list. So now when I have this code, which means this is going to left to right. This will tackle our problem of going from left to right. Now, right means I need a left, I need a right. So left is always 0 because we will be starting from the leftmost column, and top will be 0 because we will be starting from the topmost row. But then what is going to be my right? So my right is going to be let's say bottom. So my bottom is number of rows, which is matrix dot length minus 1. So here, because the indexes start from 0, so matrix length is 3 minus 1 2, which is 0 first row, 0th row, first row, and then the second row. Okay, and I need number of columns. So let's say I say matrix 0 dot length minus 1. Okay, so now I have the dimensions of my matrix. Now here I okay, let's just return this result so that the compilation errors are gone. Now when you design a solution, you have a logic in mind. Slowly and slowly you will convert that logic to the code. So I have the logic which works for left to right. Let's test this logic. So here I am going to create this class object. Spiral matrix is equal to this, and then sm dot, what's the function name? Spiral order. Okay, and here I am going to pass an array, okay, which needs to be a two-dimensional array. So what I'm going to do here is, let's say new int 2D array, and 1 comma 2 comma 3 comma 4, that is my first row. Then 5 comma 6 comma 7 comma 8 is my second row, and 9 comma 10 comma 11 comma 12 is my third row. Looks good. And let's put a breakpoint here and let's debug it. So let's do this one. Okay, so I'm going to step over or F10. Okay, F10, 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 F10. Now let's see what is the value of, let's put all of them. Left is 0, top is 0, bottom is 2, and right should be 3. So looks fine. Okay, now come here. This is 0th row and 0th column, which is 1. So as soon as I execute this line, my result should have one index with value 1. Looks good. Should be 2. So then second is 2, then 3, it's 3, and then 4, and 4, and then I'm going to break out. So this is looking good. Second, um, now what we want to do is we want to go from top to bottom. So again, same logic, int I is equal to 0, I less than bottom, I plus plus, and result dot add matrix. Okay, so now my column is static and my rows are going to increase. So my rows are variable, but my column is, so this should not be 0, this should be right, because I am adding the rightmost column, and at this time the rightmost column is the fourth column or the index 3, right? I think same way we need to fix it. This should not always be 0 0, this should be top, because my top is going to change as we move forward. Okay, so now this one is top to bottom. Okay, good. Now let's write, now once we are at the bottom, we need to go from right to left. So right to left for int I is equal to 0. Oh, so this should be going from right to left, which means it should start from right minus, it should start from right, because our right is actually doing -1 here, which means it is good for indexes which are starting from 0. So I don't have to do right -1, because our indexes are good for the when we are starting from 0 to right or right to 0. Okay, then I should go to 0 and I minus minus. So from right to left, right? So now you see some of the logic I am building pretty quickly, because I have done matrix. I know all these things already. I have done such kind of coding a lot of times. So maybe you will have to think a little. But when I'm doing this code and making this logic should come naturally to you, that how you are using the indexes to go from left to right or right to left. Okay, that logic you need to build yourself, which I cannot teach you. I can teach you the concept, I can teach you the intuition, some strategy of building, but eventually when all this strategy has to be converted to code, you should have good amount of experience to do such coding. Okay, so right to left is result dot add matrix something. Okay, so now when we go to right to left, my row is what? The bottom row, and my column is changing. So this, so which means if I am going right to left, which means I am always on the same row, but my columns are going from right to left, which are actually decreasing. So whatever right is, it should keep on decreasing, and this is the logic. After that, I need bottom to top for int I equal to, so bottom to top means I need to start from bottom and I need to go to I need to go to top, right? So this cannot be 0, right? And I minus minus. So then same way, when I am going from right to left, I am not always going to 0. I am actually going to the leftmost side. So this should be corrected. See how I am correcting. As soon as I am seeing that I made a wrong logic, I am correcting it. Okay. So similarly, I am going from top to bottom. So this should be top actually and not 0. Similarly, left is left and not 0. I think this is looking good. Let's add again. So result dot add matrix, something here. Okay, let's see bottom to top. So bottom to top is, this is bottom, we are going on the top. So column is same, which is the leftmost column, and row is changing. So column is going to be left and row is changing. Okay, let's debug it and see if we are getting good results. Okay, let's keep an eye on all these variables. So we are on the leftmost column and we need to go to the rightmost column and keep adding values. So after this loop, we will see. Okay, so result should have 1, 2, 3, 4. 1, 2, 3, 4. Looks good. Now from top to bottom. So top to bottom, because we already did that, we should be getting 8 and 12 when we finish the second loop. Okay, so result, okay, let's see. Okay, see, now there is a problem. We get 4, we got another 4, which means we got 4, and then when we want to go down, we started from here. Now see that what the problem is, we have already parsed this row. So as soon as you are going from left to right, you don't want to come to this row ever, which means my top should be 1 now, because at this time top was 0. I am done. My top should be 1, so that when I start here, my top will be 1, which means I will start from the second row. So I will be starting from 8. So let's stop the debugging and change top plus plus. Now, as soon as I parse the first row, my top will be pointing to the second row. So now I know there is a mistake. I am going to fix all of the loops. When I am going from top to bottom, which means top, top, I'm sorry, from top to bottom here 8 and then 12. So once I am going from top to bottom, I am parsing the rightmost column, which means after that loop, I don't want to come to this column, which means my right should be changed, and right should be 1 less, because from this right, my next right will be this one. My next right will be 3, 7, and 11. So after that, let's do right minus minus. Okay. Now similarly, when I'm going from top to bottom, now after that, as soon as I print 12, so my right is 1 minus, which means my right was 3. Now my right is 2. So I will be starting from 2. So which means I will be starting from 2. 0, 1, and 2. Okay. So now once I am done with this row, I don't want to come to this row, which means when I'm doing right to left, I don't want to come to the bottom again. So this means my bottom, which was 2, should be 1. So I am going to, okay. And then when I am going from, what is that, left to right, top to bottom, right to left, yes, bottom, and then bottom to top. So bottom to top, which means bottom to top, we are parsing the leftmost column. Once we are doing that, I don't want to come to that left value again. So left should be plus plus. Okay, let's see. Okay, okay, so my results are 1, 2, 3, 4. After 4, 1, 2, 3, 4, I am going to do top to bottom, but top to bottom, I am not going to start from the first row. Actually, I am going to start from the second row. So only 8 and 12. And I actually incremented top plus plus. So when I do top, starting from top, my top is not 0. My top is actually 1. See the value of I here. So I am going to print 1 and my right is 3. So I'm going to print 1, 3. Okay. So my row will be 1. This is 0th row. This is 1th row and 3. So I'm going to print 0, 1, 2, 3. I'm going to print 8. Let's see. Okay, looks good. Next. Okay. Here is the problem. See, now we printed 8 and my loop broke. And I did not print 12. Why? Because this should be equal to, right? Okay, let's do again. See how I'm building the solution. So you once you do on the LeetCode, I know you cannot debug, but you need, what you have is your practice. So once you do all this practice, debugging, and you have solved like 100 or 200 LeetCode problems, then it becomes very easy for you to directly do on LeetCode. But when you are doing for the first time, you are building logic, all these needs to be, started from scratch, take baby steps and build logic, do debugging. This will give you a good exposure of how you tackle a problem and build a solution. Okay, like I am doing. Okay, so my second loop, okay, this time it looks good. So I should have, my last value should be 12. Okay, this is good. Now I am doing right minus minus, because once I am done with 12, I don't want to come to this column again. Okay, now next time when I do a top to bottom, I should be starting from this right, which is not 3, which is actually 2. So when I do right minus minus, you see my right is, I will just, yeah, my right is 2. Now from right to left. So when I'm doing right to left, I printed 12. So I should be starting from 11, 10, and 9. And because my right was 3 and I decremented it, so then my right is 2 now, which means I will be starting from here. So see, let's say what we are doing. My bottom is 2. You see that? And my right is 2. Okay. So I am going to print 2 and 2, which is 11. Okay. So 11 and next should be 10 and next should be 9. Okay. So let's see. 11, 10, 9. Good. Now I don't want to come to this bottom. Same logic. So bottom will be 1 now. Bottom is 1. So once I am done with this bottom, now my bottom is pointing to this row. And my top is also pointing to this row because I have already done with this top. Okay. So which means my top and my bottom both are 1. Okay. Now we want to go from bottom to top. So when I want to go from bottom to top, I only have 5 to be printed because 1 is already printed. So this loop should run only once. Good. Let's see. Okay, 5, right? And same logic, I don't want to come to this left again because I am done with 5 and I was doing bottom to top. So when I'm doing bottom to top, I don't want to come to this left. So I did a left plus plus. Okay, so this looks good. Now what? We did not print 6 and 7. So this means if you are thinking, we want to do all this logic again and again, correct? Yeah. So we need a loop. Let's stop it. So Okay, let's make it simple. I need a while. I haven't thought of how many times this loop will run or what should be the ending condition of this loop. Let's see. Okay, let's say I don't have a ending condition at this time. Okay. Um, where is my result? Why the result is this is fine. Why there is an error? Unreachable code. Okay, let's see why it is saying unreachable code while true. I think this is fine. Okay, let's see. I don't know. Oh, unreachable code because there is no ending condition where this loop should be ending. Okay, let's say I say while, just for the sake of next iteration, I will take a temp. Temp is equal to 0 and I say while temp is less than equal to 1. Okay, and temp plus plus. I think this will allow it will allow me to run this code. So we are done with the first iteration where we see that we were able to print until 5, but we were not able to print 6 and 7. So what I'm going to do is put a breakpoint here and continue, because when I reach from here to here, my first iteration will be done. Okay, now I want to focus on next iteration. So I came here, I am again going to go from left to right, and my left is 1, which means this column, right? And my right should be 2. Yes, my right should be 2. So I will go from 6 and I will go up to 7 only. So you see this. Okay. At this time, my whole spiral matrix is printed. You see, from 0 to 11, there are 12 values. Okay. And the last value is 7. So now here, I need to break my loop. That's where I am done. So what should we do? There are, okay, there are many ways. I mean, everyone will create their own logic. Let's see, I will say while true, but I think one of the simplest rules is at every loop, once you are inside the loop, so if you are going from left to right, top to bottom, right to left, or bottom to top, either you start a loop or you don't. Once you are in the loop, you will do the full exercise, which means if you want to do left to right, so you will start from 6 and you go up to right. Similarly, if let's say you want to go from bottom to top and 9 is done, 1 is done, but still you will enter the loop, and once you enter the loop, you will definitely do something. At least you will print one value. Okay, so this means we will, after the loop ends, we need to check, because if we are going inside this loop, we are in a good state. And once this loop ends, we need to check. So the easiest is, what is the size of this array? The size of this array should be, let's say, size should be bottom into right, right? 4 into 3, 12. So we should have 12 digits for this problem. So once this loop ends, if I check that my result dot size is equal to, or let's change it, uh, total elements is equal to total elements, we break. Right? Simplest. And we can just copy it after every loop. What is happening? Copy, paste, paste, and paste, and remove this temp logic. Right? Makes sense? We can do other things also, like we can do just before the loop. What we can do is, let's say we want to go from left to right. When can we go from left to right? If my left is at least equal to right. Okay. In that scenario, I will print at least one element, which means, or take an example again from bottom to top. So if when I'm doing bottom to top, so where I am here, so I need an I, which is bottom, and I need a top. Okay. These are two of my constraints. So if my bottom and top are same, which means my bottom is 1 and top is also 1, but still I'm going to print 5. Okay. So what we don't want is, in this scenario, if my left is greater than right, we are done. We cannot go on to the left, and if we cannot go to the right, and if we cannot go to the right, we cannot go anywhere. Okay. So either you can have this logic, or you can have, if your left is greater than right, you are done. Right? This is another logic. So you can make any, it's just, if there are 10 students in the class, maybe 10 students will come up with 10 different ways of, fixing this problem. So I use this, but you can also use that other logic. Like here also, I am going from top to bottom. Okay. So which means my top should be less than equal to bottom. But if my top is greater than bottom, I cannot go from top to bottom. So I can check, if my top is greater than bottom, break. Okay. So now let's just work with this. This is my first iteration. We have already tested it. So I will put a breakpoint at the end of the first iteration. Press F5 or press continue. What happened? Something is not right. Something bad happened. Let's run again. So bottom is 2. There is a problem. See, 3 and 2. What we are checking is, this is 6 actually. We need this to be 7. Why? Because we have subtracted 1. So although my bottom was 4 and my bottom was 3 and my right was 4, we subtracted it. So it became 2 and 3. So we actually want the real lengths. Okay, this should be fine. Let's see. 9. Uh-oh. I think this thing has some problem. Control C is not working. Yes, 12. Okay. Now we should be reaching at the end of first iteration. Okay, great. So now we came here. Now we are going from left to right. So because we can go from left to right because my left is 1 and my right is 2. So we will do first one index and the 2 index, which means this loop will run for twice. I equal to 1 and I equal to 2. Right? That's it. Now here I am done. 0 to 11, 12 elements, and that's it. We are done. Let's take so now you can create maybe a couple of more test cases. Once you think you're satisfied, submit on LeetCode. See if your submission is accepted. If not, it will tell you some of the test case. Figure out the problem in your code, fix it, try submitting again. And I think that's how you will build some logic. Okay. Okay, let's take one more example. I have taken an example for you, which is 1 minute. LeetCode problem 287, I think. Ooh, I need to search. Yeah. So LeetCode problem 287 is find duplicates. Okay, let's design a solution for that. So I will create another class and I will give it a name, find duplicate number LC287. Okay, and I think public int find duplicate. There is an array of numbers and what I need to return is the duplicate number. So let's take an example here. Let's create another object here. FT find duplicate. Okay, FT dot find duplicate, and I'm going to pass, let's say 1, 3, 4, 2, 2. Okay. Okay. Remove the error, just return something random. Okay. So we have this. There are multiple solutions. Let's say you know solution or you don't know the solution. Let's say you don't know the solution and you are going to solve it in a very naive way, which might not be the best solution, but let's say you came up with this solution only. You are given this problem to solve and you have not seen this problem before. So what are you going to do? I think most of the students will come up with, so okay, what the problem is? The problem is you have an array which has numbers from 1 to n. And in this case, I have numbers from 1 to 4. Okay. And the length is going to be n plus 1 plus 1. And in this case, it's 4 plus 1 equal to 5. Okay. One to n, right? So that is the constraint of the problem. So let's say the easiest solution we can come up with is I create an array of n, of length n, which means I will have 3, 4, 5. Okay, I created this array. Okay, now when I see 1, I will make it true. When I see 3, I will make it. When I see 4, oh, I'm sorry, 1, 2, 3, make it true. When I see 4, make it true. When I see 2, make it true. And when I see another 2, so every time when I am setting it to true, I will check if it's already true or not. If it's already true, we have found the duplicate. Very simple solution. The only problem is we are taking a memory of 1, 2, n plus 1. That's the problem. So if your interviewer or the problem does not state that you cannot take extra memory, this solution is fine because this will run in on time. We just parse once. Okay, keep setting this boolean and that's it. So let's try this. Okay, so what we need, I think we are good with the logic in our mind. We need to create an array. So first of all, int what name I should give it to, values seen, and this should not be int, this should be a boolean. Okay, new boolean, and this should be nums dot length. Fine. Okay, now let's do a loop for I equal to 0, I less than length, I plus plus. Right now, what we want, if the index is not true, we set it to true. So if value seen not equal to true, set it to true. Right? Else it's true. Just break. That's it. Break. So, but if we break, how do we know what was the value of I? What we can do is we can just return. Let's return I. Okay, so that's it. If we see the value, we will return I. If the loop breaks and our code never goes here, we have not seen the duplicate. and we are going to return -1. Simple. Let's see. Put a breakpoint here. Let's remove the breakpoint from the previous problem. Do F5. Okay, this was the previous problem. Yes. So now nums is 1, 3, 4. So first time value 0 is false. Set it to true. Good. Second, again, set it to true. Third will be 4. Never seen. Set it to true. Then 2. Never seen. Set it to true. Another 2. We have seen it. It's true. Oh, 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 what happened? Okay, 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 okay. That's not good. It should not be I. This should be the value. So this should be the value, right? Okay. See, so when you debug, I made a logic. It was not right. I fixed it. We'll run again. So let's see. Num I is where is my watch? Here is my watch. Let's remove the previous ones and put the new ones. Num I is 1. So, okay. Now, okay. So let's put that also in the watch. Okay. Now this one, num I is 4. Oh, I made a mistake. I also need to set this. So we are checking if we add that index, it's not true. Set it to true. Okay, now looks fine. Okay, so num I is 1. 1 is false. Good. True. Now it's 3. So the third index is false. Okay, good. 4. Okay, true. Good. Now second. So this is false. This will be true. Okay, this is true. Now next. Now this is true because num I is 2 and 2. 2 is already true. We have seen it. So it should be going here. Nice. And see, now this is another mistake. 4 is not duplicate. Num I is duplicate. Very bad. Okay, good. Let's see. Run again. Okay, second, third, fourth. Yes. So num I is 2 and it's already true. That's it. Simple. Done. I think one of the things I am not liking about this solution is our numbers will be 1 to 4 and we are never putting anything in index 0, although it should not matter because we will have numbers from 1 to 4 and the array will be 1 to 5. So we will never go out of bounds. This is fine. But if we want to utilize the 0th index, we can always do -1. So 1 will be 0, 2 will be 1, and so on. But here we want to return the actual number 2. So we can do this way also. Let's see. So num I is 1, which means we need to set the 0th index to true. zeroth index to true. Okay, next time it's 3, so we want to do the second index to true. Okay, second index to true. Third time we have 4, so we want to set third index to true. But even if we had set fourth index to true, we will never go out of bounds because the maximum value can always be 4 and my maximum index is also 4. So both solutions were fine. I just wanted to do this. Okay, this is true. Now we got 2. So the first index will be made true. Okay, true. And now this is already true. So we don't want to return -1. We want to return actual value. So here we are returning num2, which is 2. And that's it. This is another way of doing. Okay, now, so if your um, problem says you cannot take an extra auxiliary memory, then you will have to find a way to figure out how you are going to do that. There are, I mean, when we talk about auxiliary memory, this was one way. You could have taken hash map or something where you can just count if any of the index is true or if any of the index value is more than 1. But all those solutions are same. You are taking an extra memory. So those solutions will be rejected if your interviewer asks you to do something without extra memory. So let's see. Um, let's try a different one without extra memory. But this solution, okay, so here asymptotic complexity is time n and memory is n. Okay. And we want constant memory. So then this solution is not good. Let's say I name it 2. Okay. Remove the compilation error by returning something random. Okay. So now this is a standard solution, and if you don't know this solution, it's not easy to come up with this solution. So when you do LeetCode problems, you have experience, you should be remembering the concept or the logic or the strategy, but you don't have to remember the code. Don't remember the code. Just remember how you solve find duplicates problem with extra memory and without extra memory. So we do a binary search when we don't want extra memory. This is the only thing you need to remember. You don't have to remember how you are going to code it. Okay. So what's the concept of this? Let's see. Second solution. Doing binary search, not searching indexes, but instead values. Okay. So what actually happens in binary search? We have an array, we sort it, and then we search on the values, right? I mean the values on the indexes. So our left, right, and mid are actually indexes in the array, right? If you don't remember, just go and have a look how binary search works. So if you want to do a binary search on this, you take out mid. So let's say your mid is index 0, 1, 2. So your index is 2. And let's say you want to search 5. So if 5 is greater than 3, the value on index 2, you go on to the right. So then your left is 0, 1, 2, 3, 4, 5. 3 and 5. So 3 and 5, the mid is 4. 0, 1, 2, 3, and 4. So then you are creating your left, right, and medium values to be the indexes in this array. So next time, first time the index was 2, second time, not index, your mid, right? Your mid was 4. So you see, you are creating indexes and then you are checking the values on those indexes. This is binary search. Here, we are not going to do that. It's different. It works like binary search, but we work on the actual values we have, which might be on any index. I don't care. So let's take an example. Uh, let's say this. Delete it. Okay. Uh, let's change it. Let's change it a little to make it more easier to understand. Okay. So let's say I have this array. Now, the idea is I have values from 1 to n, which is 1 to 4. So my mid will be 1 to 4 divided by 2. 1 plus 4 divided by 2 is equal to 2. Okay. So I am not going to sort this array. I am just taking my, what is my minimum value, which is 1, and what is my maximum value, 4. So the mid is 2. Okay. This means now what I'm going to do, I am going to scan this array for values which are less than or equal to 2. So 1, 2, 3. Okay. So my count is 3 which are less than 2. What does that mean? This means on, if you have an array which goes from 1 to 2, but you have 3 values. So you have 2 indexes, but you have 3 values. This means you have a duplicate, okay, in that array. And what we did, we actually tried to find the values less than 2. So the values less than 2 are not 2, but instead 3. This means left side has the duplicate. So left side, when I say left side, it does not mean left side of the mid of this array. This means left side of 1 to 4 and the mid is 2. So on to the left side of mid, which means either 1 is duplicate or 2 is duplicate. Okay. So when we see that we have this, my count is 3 count values less than equal to mid is equal to 3. So we need to take a decision. So what we do is, because for a mid of 2, we got 3 values. So for a mid of 2, if we have got 2 values, which means then the duplicate is on the right side. Okay. But we got 3 values. So whatever mid is, if you get those values greater than mid, it's on the right side. If you get values less than mid, I'm sorry, if you get values greater than mid, it's on the left side, otherwise it's on the right side. Okay, so we got 3 values and our mid was 2. So in an index of 2, we have 3 values. This means the duplicate is towards left. Okay, and when it's on the left, I need to search only from 1 to 2. Okay, so what I say is, here my mid was this. If you see this, so let's say my low was 1 and my high was 4. So when I take this decision, this is my iteration 1. In the iteration 2, because of that decision, my low will be 1. Okay, now in binary search, if we go on to the left, let's say left of 4, we only parse whatever is on the left of mid, so only 2 elements. In this, we are going to parse the whole array all the time. So just stay with me, listen to this. Maybe you will have to listen again. When I code, this will all make sense. Okay, so left low is 1, and when I am staying on the left side, my mid is 2 and my high is 2. So, or let's say mid is equal to high is equal to 2. Okay. So now what we need to do is, we need to see sorry, high is 2 and my mid is 1 plus 2 divided by 2 is equal to 1. Okay, so we will do the same thing again. Count values less than equal to mid equal to 1. So we will scan this array again, this one, this one, this one, only one value. So my mid was 1, decision, let's say decision. For a mid of 1, count of values less than equal to 1 is 1, which means we cannot have 1, or we cannot have any value before 1, although there is no value before 1. But when my mid and the count is either same or less, which means I don't have the duplicate until or up to the value of mid. Okay, so let's say, for example, this time in iteration 2, my mid would have been 3, and let's say my count of the values which are less than equal to 3, maybe 2 or 3, then the duplicate is not in the range of less than 3. So 1 is not duplicate, 2 is not duplicate, 3 is not duplicate. Okay, so in this case, what I'm going to do is, because I know on the left side there is no duplicate, it should be on the right side. So what I'm going to do is I am going to change my low to low will be mid plus 1, and my high will stay like that. Okay. And means the duplicate is on the right. So when the duplicate is on the right, then I will change my low towards the right side. So my low will become mid plus 1. High will remain same. Okay. When I went on to the left side, my high was the current mid. Okay. So I can say this also. Okay. And here high will remain same. So high will remain high. Okay. And mid will be mid will be 2 and high was 2, and let's just write 2 so that we know. So this is 2 plus 2 divided by 2 is equal to 2. Okay, iteration 3. So before every iteration we check if low is equal to if low is equal to high, we break. So here my high is 2 and my low is 2. We will break. And answer is 2. So this is the whole logic. Let's try to convert this logic into code. Okay, so what we want? First of all, we want a low, a mid, or high. Okay, so my low will be when we start. Low will be 1. High will be nums dot length minus 1. So the length of array is 5, but the values are from 1 to 4. That's why its values 1 to 4, but the length of array is 1 to 4, 1 to n, and the length of array is 1 to n plus 1. Okay. So the length was 5 and we subtracted 1. So we get a high of 4. So like this here, 1 to 4. So we got high, we got this. Now as we said, we need to run a loop until low and high are equal. So let's say low, high. Okay, good. This is the loop. We need to take out mid. Mid is equal to high plus low divided by 2. Okay. And what we want? We want count because that's what we will use. So count is 0. Okay. So now we have low, we have high, and we have count. What we want? We want to run to the whole array and see how many values are less than or equal to mid, right? So for int I equal to 0, I less than nums dot length I plus plus. If nums I is less than equal to mid, we increment the count. Right? Make sense? Now we need to take a decision. So that's what we created. We did a count. We take a decision if we want to go to the left side or we want to go to the right side. So if my count is greater than mid, like in our first iteration, my mid was 2, but my count came out to be 3, right? So then we want to go to the left side, which means my high will be equal to mid, correct? Else I am going to shift my low to the right side of mid. Okay, so my low will be mid plus 1. So if we have, so don't look at this array, look at the range of values, then you will be able to understand. So my mid was 2. I checked how many values are less than equal to 2. So 1, 2 and 3. So we have 3 values in a range of 1 to 4. Okay, which means the duplicate is on the left side of mid, which means either 1 or 2. Don't look at this. This does not mean the value is either 2 or 3. No. Look at the range. The range is 1 to 4. And when we are going on to the left side of that range, the mid is 2. So the left side of mid inclusive is 1 or 2. So what we say is, if we want to go from until 2, then my high is going to be 2, my low is 1. Okay, so we want to search in a range of 1 or 2. If otherwise my low is going to the right side, so we will search in the range of 3 or 4, because 1 and 2 is on the left side, so 3 and 4 will be on the right side. That's the logic. Okay, so that's it. Now what is the ending condition of this while loop? The ending condition of this while loop is, now I take a decision. After the decision, okay, let's see. Let's try to run it and see what happens. So I will, okay, now low is 1. Oops. High, mid, count. Okay, low is 1, high is 4. Let's go in. Mid will be 2, mid will be 2, count is 0. So now in the array, we will check how many values are less than mid, which is 2. So 1. Okay. So there are 3 values which are less than or equal to mid. So if the values are, the total count of values which are less than or equal to mid is more than the mid, we shrink onto the left side. So my high will come to the mid. So now my high becomes 2, right? And we go on to the top. Fine. So now my low is 1, my high is 2. Okay. My mid is 1. Okay. Let's again run this loop and see how many values are less than or equal to 1. Okay, so count is not greater than mid. Count is 1 and mid is also 1. So we want to go on to the right side, which means value 1 or anything below 1 has no duplicate. It's on the right side. So then I will change my low to the right of mid. Mid was 1. So now my low will be mid plus 1. So, okay. So now low is 2, high is 2. Okay. While low is 2, high is 2. Okay. Mid is 2. So now I think the solution should stop here, because low and high both are 2, and we see that this array has number 2 as duplicate. So I think when we enter the loop, wait, if we check, and that's the ending condition, right? If low is equal to high, we break. So if low is equal to high, uh, low is equal to high, we just know that either low or high is the duplicate value. So let's run it. F10. Okay. So first iteration ending, and we will go on to the left side, which is fine. Second iteration, we will go on to the right side. Okay. So now my low is 2 and my high is also 2. That's where I need to end. I think that's it. Let's take maybe one more example. I am taking the LeetCode example 3, 1, 3, 4, 2. Okay, let's see. Okay, so my range is same. 3, 1, 3, 4, 2. So the range is 1 to 4. Okay, and so low is 1, high is 4. Okay, let's go in. It's not meeting the condition. Mid will be, I think, 2. Yes, 2. Now let's see how many values are less than 2. So how many values are less than or equal to 2? 1 and 2. So see now, my count is not greater than the mid. Before, in the previous example, my mid was 2 and I got a count of 3. So I went on to the left side. But here, my mid is 2 and my count is also 2. It's not greater, which means the value is on to the right side. So low is going to be shifting towards the right. So my low will be 3 and my high is 4. Okay. So I am going to search between 3 and 4 inclusive. Okay. So then 3 and 4, which will be, I think, 3. So my mid came out to be 3. Okay. So I'm going to search for values which are less than or equal to 3. So there is 1, 2, 3, and 4. Ooh. So then the solution will be on to the left side. Okay. So then my high will be equal to mid. And I think that's where we will satisfy. Okay. So low is 3, high is 3. Oh, so this is working. So that's how, you will design a solution. You will think about the logic. Now I have to agree that for the binary search logic, you need to know this concept. Otherwise, it is really hard to come up with a solution. So I knew the logic in the sense concept that I can fix it using binary search. And that's where I was able to design this solution. Otherwise, maybe it was tough for me because I really, not in my dreams will think about such a solution. Or maybe, I don't know. So I have, in this session, I have given you few examples of how you design, think, write a logic before you actually code, and then you convert your logic into the code. So once you do the code, the logic, in the logic you will have all the variables, kind of pseudocode, and then you will convert exactly like your pseudocode into the code. We saw the spiral matrix where we thought of a logic, slowly built the logic. So that's how you can do it. I will, maybe in my next session, I will include a couple more examples to show you where I already maybe come up with the concept, or I already know the concept. Then I create a high level logic or pseudocode and then convert that to the code. So maybe I'm just going to end this session here. I hope it was informative and help you designing your solutions. If something does not seem natural, I will, ask you to watch a couple more times, then spend some time alone thinking about it. Spend as much time as you want. Don't leave the problem in between, even if it takes hours. Because even if you take hours and solve one problem, that is going to give you a great amount of experience. And the next problem will definitely take less time. So don't leave problems even if you are not able to design a solution. Just keep working, debugging, slowly fixing it, and coming to, a perfect solution. Okay. So I will end the session here, and we'll see you in my next session. Until then, thanks for watching and bye for now.